We continue with chapter 8 and we'll be looking at example 7 and 8 today. But before that, let us look at the formulas of expectation and variance of Poisson distribution. Expectation is also known as mean or average. If X is a Poisson distribution with mean lambda, then the expectation Ex and variance of Poisson are just lambda, and remember that Ex or the expectation is also mean or average, and the formula for variance as well is lambda. Let us now look at example 7. Question for example 7. The number of calculators sold by a bookstore follows a Poisson distribution with a mean of 9 calculators sold in 4 days. What is the mean and standard deviation of Y, which is the number of calculators sold in 3 days? And what is the probability that fewer than 3 calculators sold in 3 days? B. Find the mean and standard deviation of W, which is the number of calculators sold in 7 days. The interval here is 4 days. So 9 here is the mean or lambda for 4 days. The first part of question A is asking us to find the mean and standard deviation of Y. So let Y be the number of calculators sold in 3 days. We need to find lambda for 3 days. Remember that the lambda for 4 days is 9. So to find the lambda for 3 days, first we need to find the lambda for 1 day. How to find that? 9 divided by 4 days, and multiply with 3, and we get lambda for 3 days as 6.75. So now we can write Y as a Poisson distribution with lambda 6.75. So to find expectation Y, remember the formula of expectation. Expectation is equals to lambda. Therefore, expectation Y is equals to 6.75. To find standard deviation, first we need to find the variance of Y. And remember, formula to find variance of Y is also equals to lambda. Therefore, standard deviation of Y is equals to the square root of variance Y. And the answer is 2.598. We continue with the second part of question A. Y is number of calculators sold in 3 days. And from the previous part, we have found the lambda for 3 days, which is 6.75. The second part of question A is asking us to find the probability that fewer than 3 calculators sold in 3 days. So fewer than 3 means less than 3. Less than 3 means 3 is not included. So therefore we list down the probability of Y equals to 0, Y equals to 1, and Y equals to 2. So this after we substitute the values into the formulas. And to make our calculation easier, we factor out the common factor here, which is e to the power of negative 6.75. And then that is our final answer. Question B asking us to find mean and standard deviation of W, which is the number of calculators sold in 7 days. So we let W as number of calculators sold in 7 days. So to find lambda for 7 days, just like how we found the lambda for 3 days, first we need to find the lambda for 1 day, which is 9/4, and then we multiply with 7 days, and the answer is 15.75. So now we can write W is the Poisson distribution with lambda 15.75. Expectation, W is equals to lambda, and lambda is also equals to variance. Therefore, the answer for expectation and variance of W is 15.75. Example 8. Question for example 8. Farah is a typist. On average, she makes 2 typing errors per page. Assume that the typing errors are distributed as Poisson distribution. Question A and question B. Before we look at the question, let us analyze this. Our interval is per page. It means that 2 typing errors here is the lambda per page. So if you look at question A, we are asked to find the probability that there is at most 3 errors in 2 pages. So we know the drill here. First, we need to find the new lambda. We are given lambda per page. So here we need to find the lambda for 2 pages. And then after that, we find the probability for at most 3 errors. But if you look at question B here, it says that Farah has to type 7 documents. It looks like this one is a binomial and we have 7 number of trials. And the probability of that is, we can see the similarity here, at most 3 errors in 2 pages, at most 3 errors in 2 pages. So the probability that we found here is actually the probability for type 7 document. And then we have to find the probability of at most 2 out of these 7 documents. It looks a little bit confusing, but let us continue with the solution. Let us solve question A, example 8. So let Y be number of typing errors in 2 pages. Remember that the error or the lambda for 1 page is 2. So to find lambda for 2 pages, we multiply by 2. So now we can write Y as a Poisson distribution with lambda 4. Question A is asking us to find the probability that there is at most 3 errors in 2 pages. At most 3 means the maximum is 3. So therefore, we have to write Y equals to 0, the probability of Y equals to 0, probability of Y equals to 1, 2, and maximum is Y equals to 3. Substitute the values into the formula, and to make our calculation easier, we factor out e to the power of -4 since it is the common factor here, and that is our final answer. So solution for question B, example 8. Let V number of documents with at most 3 errors in 2 pages. So we are not talking about number of typing errors in pages anymore. We are talking about number of documents, and we have seen from the question that there are 7 documents altogether, which is 7 number of trials. Therefore, n is equals to 7, p is 0.4335, which is actually the answer for question A, and q is 1 minus p, so 0.5665. So now we can write V as a binomial distribution with number of trials 7, and the probability of getting success is 0.4335. So the question is, what is the probability that Farah makes at most 3 errors in 2 pages in at most 2 of the document out of 7. So at most 2 means maximum is 2. So therefore we have to find the probability of V equals to 0, equals to 1, and equals to 2. So remember the formula of binomial. Substitute the values into it, and this is our final answer. That's all for today. Thank you, and have a nice day, everyone. Bye.